The first truth arrives not as a dictum, but as a sensation. Something from the cold between stars has broken the stillness of our familiar arithmetic, gliding into the sun's dominion with the dispassionate grace of a theorem that refuses to fit on the chalkboard, and for a breathless span we feel the floor of certainty flex under our feet. We have catalogued wanderers before, icy bodies and dusty messengers that speak in the dialects of sublimation and gravity, but this one enters with a confidence that seems almost aesthetic, like an instrument tuned to a physics deeper than the one we use each day. We give it a name, 3I Atlas, because names help our nerves. We wrap its apparition in numbers, an apparent magnitude that waxes and steadies, a coma that hints at organic richness, a tail that does not behave quite like a tail should. And then the path, always the path, draws the breath from our lungs. The fit is good until it isn't. The residuals tighten until they don't. We tug on our models as if on reluctant sails, and they snap, and the object, indifferent, writes its signature in the sky. In the heart's quiet chamber where science and wonder share a wall, we feel a pressure we know from childhood, the pressure of a door about to open. We should begin at the beginning, which is always a snapshot stitched from many eyes. Time stamps from a global ballet. Atlas first flags the moving point against a quilt of known stars. Pan-stars follows with sharper photometry. Amateurs, those stubborn saints of patience, fill in the cadence gaps with small glass under big skies. The early solutions speak hyperbola with a clear accent, an eccentricity above one, a V infinity that is not borrowed from a planetary slingshot, but carried from birth, from the long, cold drifts beyond any leash of our sun. This is interstellar, the third of its kind recorded by human hands, the third letter in an alphabet we are learning to sound out. The brightness curve hums. A taxonomist would call it cometary by habit. There is a coma, there is dust, there is a slight color that leans toward the reds of complex carbon chains, and yet the timing of its outgassing, if that is what it is, disobeys the old snowball narrative. There is no waltz of jets that we can tie to solar heating with the neatness we crave. The spectrum makes promises it will not keep. Faint CN bands, a muted water signature, traces that suggest metal-bearing grains, and a thermal behavior that implies a surface which neither absorbs nor releases heat in the way our datasets expect. In the margins, observers scribble, unusual phase function, low albedo but high forward scatter, area to mass may be large. Those phrases are puzzle pieces looking for a border. When a mystery walks in, the first habit is to ask the photons what they saw. The photometry, faithful witness, tells us that the light curve is neither purely geometric nor purely volatile. There's a modulation that could be rotation, a period that teases at a few hours, then shifts towards something longer, then refuses to be nailed down. Perhaps a tumbling body with a complex moment of inertia, perhaps a braided bundle of fragments rotating in sympathy. The spectroscopy is coy but not mute. We glimpse a continuum that darkens in the blue, consistent with Tholen-like organics, and a thermal slope misaligned with naive equilibrium models, suggesting a roughness at small scales, a surface that traps light like a labyrinth. Radar returns are too faint to sketch a shape, but their absence is its own clue. Cross-section modest, composition not strongly metallic. Meanwhile, the precise astrometry, the workhorse of modern celestial mechanics, draws its crisp pencil lines night after night. Fit a pure Keplerian path, subtract, and the residuals whisper, there is a push. It is not erratic in the way coma jets dance. It is smooth to a degree that dares us to accuse our instruments before the object. But across instruments and sights, across pipelines and calibrations, the whisper remains, a non-gravitational acceleration with a sign aligned with solar radiation pressure, a magnitude slightly too large for any simple grain-shedding story, and a radial component that seems to pivot subtly with phase angle, as if the body's reflective geometry were complicit. We have seen hints of this before, the way Oumuamua puzzled us with a gentle shove that refused to stutter like steam, the way 2I Borisov reminded us that some things are beautifully boring. 3I Atlas lands between those memories, with just enough discipline in its anomaly to sound like design and just enough dust to sound like ice. And then comes the mischief in the numbers. Between perihelion and the outbound leg, the fit begins to insist that radiation pressure alone would require an implausibly high area-to-mass ratio unless we grant the body a skin that glitters like a sail. But the phase function's sheen is not quite brilliant enough to make that easy. The pow. Photometric slope suggests something intermediate, as though the surface is a collage of dull and bright, rough and smooth, with microarchitecture increasing the effective area in ways hard to guess. Jets? The usual suspect. Outgassing can mimic a gentle push if the jets distribute evenly and evolve with temperature. But the temperature curve does not sing the expected chorus. The modulations are offset from the simple solar heating cycle, and the spectral lines that would bear witness to water and CO are subdued, as if choked or shielded by a crust that is both porous and stubborn. Dust recoil? Perhaps, if the dust is fine enough and the emission law is oddly symmetric over a tumbling cycle. Lorentz coupling to the solar wind? Exotic, but a charge-to-mass configuration, unrealistic for macroscopic solids unless the body is sloughing charged flakes like thistledown. We test a blended model, a mild outgassing component, a radiation pressure term tuned by a fractal surface, and a rotation state that slowly precesses. The fit improves, then the period walks away again. That is when someone mentions modified inertia with a smile that means they do not believe it, but want to taste the word on the air. We are not there. We are not yet tearing Newton from the wall, but we are alert to the possibility that our priors, not our laws, are the unwelcome guests. Speculation has a place in science, not as a throne, but as a chair by the window where new light comes in. A light sail would explain the steadiness. And if you have once entertained the idea that a civilization might fold starlight into propulsion, it is hard to put the thought back in the drawer untouched. The area to mass, the alignment, the way the acceleration scales almost perfectly with solar flux, all of it would be a hymn to sailcraft. But nature, with her long workshop and her countless apprentices, can build thin things too. Exfoliated ices under vacuum, fluffy aggregates with porosities a cathedral would envy, layered crusts that fracture into plates and glissade at tens of meters per second. A relic of a rogue planet's atmosphere frozen and flaked? A shard from a tidally disrupted comet whose internal hollows turned it into a kite? If charge builds on such a structure, could magnetic draping of the solar wind add a whisper of force, modulating with the sun's capricious breath? There are still more radical corridors, dark outgassing of supervolatile species that hide their signatures by photodissociation pathways we have not fully mapped, or micronewton jets from phase change fronts buried under insulating mantles. And yes, at the edge of the whiteboard, a smaller box labeled artifact, not because we wish it to be so, not because we hunger for company, but because the duty of the scientist is to draw the full map of what could be and to walk each road until it ends in certainty or in contradiction. Coincidences, like constellations, are patterns we impose on chaos until sometimes they aren't. During a week in which 3I Atlas outbound solution grew taut, the solar wind reversed polarity in a transient that was both sharp and global. Simultaneously, Earth orbit, Inc. spacecraft recorded a dusk-side magnetotail reconnection event of unusual brevity, while in the deep field, a micro-lensing alert in Sagittarius flashed a curious symmetry. It is in our nature to braid these threads, to see choreography where chance alone would suffice. Yet timing matters in plasma, and the solar wind's change in sign changes how charged dust and rugged surfaces feel the sun's breath. The small deflections in our residuals, those tick marks that keep the analyst up past midnight, accordion subtly with the heliospheric weather. Are we seeing the body's sail-like facets angle their feathery drag as the wind's vector spins, or are we flattering ourselves with a trick of overfitting? The covariance matrix can be a carnival mirror if one is not careful, but the temptation persists because the alignment is tidy in a way that asks to be tested. Meanwhile, the light curve's queer heartbeats, those small brightening pulses, occasionally coincide with coronal mass ejections that steepen the local radiation environment, as if the object answers not to heat but to charge. Against this tapestry, it is no wonder that the words synchronized turn up in logs that pretend to be sterile. We are not declaring conspiracy among celestial events. We are acknowledging that the invisible wires between them are real, and sometimes they hum the same note at once. So we return to craft and gravity, to the sober dance whose steps we can show a student on the back of an envelope, and yet whose true music still startles us. In patched conic approximation, the sun owns the baton until Jupiter sneaks in a harmony. Beyond, the galaxy supplies the bass. For 3i Atlas, the inbound leg grazed the inner system with just enough inclination to avoid the muscular harmonics of the giant's resonances, like a skater threading a path between pools of thin ice. Yet there are weak resonances everywhere, and tiny exchanges of angular momentum pile up like whispered favors. If the body carries facets that turn to face the sun with a rhythm not quite commensurate with its spin, radiation pressure writes subtle torque on its orientation. The torque, in turn, modulates the cross-sectional area presented to the photon wind, creating a feedback that is almost a sailor's tack, a kind of photon kinematics that looks like cunning to eyes trained to see inert drama. We can calculate the slingshot as a textbook diagram, a curve steepening at perihelion, an asymptote tilting away, and still be surprised by how the outbound V-infinity inches beyond our gravity-only budget. The missing meters per second are not a scandal. They are a signature. If there is design, it is in the shape. Low bulk density, high porosity, a mosaic of plates that flutter with a complex Q factor, all conspiring to borrow momentum from light. Not reaction mass, not chemical fire, but the pure conversation between geometry and starshine. If this is natural, it is splendid. If it is engineered, it is the same physics wearing a uniform, and we would do well to study the cut. Then, like a stage cue too neat for reality, the sky closes its door for a while. Geometry conspires. The line of sight tangles with glare. A storm slaps the largest mirror on Earth. A network outage strips timestamps from the one northern site with clear air. A scheduled spacecraft roll places a sunshade edge in the wrong place for 40 merciless minutes. 37 hours later, we have a gap, an absence shaped like implication. The object emerges on the far side of that silence, not where prediction placed it, but somewhere a whisper away, enough to reset the fit, not enough to acquit our models. Suspicion grows, but caution holds it by the wrist. The blackouts of observation are where imaginations practice. They are also where systematic error waits with the patience of a hunter. Did a calibration lamp age unexpectedly? Did the flat field solution overcorrect a subtle vignetting drift? Was an asteroid innocently blended in one frame, spoiling the centroid like a faint double star? The audit trail is long and often inglorious. The write-ups are measured, and yet there remains on the page a small, unflinching fraction that refuses to be invoiced to human clumsiness. The orbit solution jumped. The jump aligns with a period in which a coronal stream brushed the object's path. It would be melodrama to read intent here. It would be unscientific to pretend the timing is meaningless. In the discipline's more private rooms, we acknowledge that mystery enters not only through wonder, but through bookkeeping. Our species has always met puzzles with plans, and 3i Atlas is no exception. The first implication is as practical as a wrench. If photon-coupled kinematics can grant tiny but steady delta V to porous bodies, then mission designers can borrow that grace. A sail does not have to shine like a mirror to work. A fabric of microtextures can sip radiation and repay it as thrust if the geometry is right. Imagine comet hoppers that angle their skins to trim their trajectories without the tantrums of propellant. Imagine scout craft that present different faces to the sun as they coast between worlds, accruing meters per second like interest. If, on the other hand, the effect is largely outgassing disciplined by microstructure, we gain a different boon: better priors on volatile retention in interstellar debris, better hazard models for close passes, better recipes for subsurface sampling where gas plumes can nudge our probes. And if the dark horse were to win, if some signature emerged that the acceleration could not be reconciled with natural structure and known physics, then the implications widen beyond engineering. Detection strategies would change. We would look not only for brightness and path, but for the fingerprint of subtle control. SETI would expand from radio and optical beacons to dynamics, from listening to watching for acts of navigation written as equations in the sky. Technology follows curiosity and funding follows technology. Small telescopes would proliferate not just to see fainter, but to time more precisely. The romance of it is obvious. The rigor of it is where we must live. From a vantage higher than our calendar, the phenomena unfolds into a longer story. The way interstellar traffic seems to be not a myth, but a slow drizzle. The way chemistry repeats itself across suns with both the monotony and the fecundity of truth. With each new visitor, we tighten the bounds on how planetesimals survive their births, on how tides shred and frost reforms, on how geometry can masquerade as propulsion. We also test our humility. The universe is proud of its patience. It has had eons to stumble on devices we have not yet imagined. A snowflake is a marvel of emergence. A porous shard that tacks on light is a snowflake scaled for space. It is not necessary to populate the void with others to feel small. Physics alone can do that. Yet the possibility that others exist, that some wanderers are messages in the language of motion, drags our gaze forward in a way that lifts the spine. For now, what we have is a curve on a graph, a set of residuals, a collection of nights that ended at dawn, with a sense that something has shifted a little inside the circle we draw around the known. It is tempting to lock our attention on the singular and forget the context of the sea it swims in. The heliosphere is not empty, it is weather. A charged dust grain's life is a saga. A porous body's outline is a consensus between photons and ions. If 3E Atlas path leans even slightly at the touch of a coronal stream, if its spin state precesses under the slow, lovely tyranny of solar torque, then the lesson is not merely local. It tells us that small bodies, the rubble and lace of planetary birth, are engines we have not cataloged fully. We can reimagine our probes to interact with that engine. Field mills to read surface charge in real time, microbolometers to narrate the dance of heat across a fractal skin, inertial sensors that can smell a micronewton like a bloodhound smells rain. Our mathematics, too, will need to be generous. Monte Carlo suites that accept the marriage of radiation pressure and tumbling geometry as first principle rather than nuisance. Covariance treatments that expect the sun to behave like a capricious conductor. The black art of orbit determination may become a brighter art, expanded to include the language of texture and torque. And the human part, always the human part, leans into the future this way. We will launch scouts that know how to wait. Not everything that moves fast must be met head-on. Some missions will be designed to linger in patient webs at the Lagrange points, their sails folded, listening to the faint murmurs of interstellar passers-by. When a signature like 3I Atlas appears, an eccentricity that won't apologize, an acceleration that aligns with light, these scouts will unfold their skins, angle themselves by millidegrees, and whisper after the stranger with the persistence of a long-distance runner. Rendezvous may be too bold a word for the first generation. Escort might be closer to the truth. We will match not speed, but cadence, falling in beside these objects the way a seabird falls in with a ship, feeling the small winds and the shape of the bow wave, what we learn. RN will feed back into everything, asteroid hazard models, sample return architectures, the subtle art of station keeping near rough things. Meanwhile, on the ground, the culture of observation will refactor around the realities of faint, fast guests. Networks of mid-sized scopes tuned for high-cadence astrometry, pipelines that interleave light curve inversions with dynamical fits, open ledgers of transient sky weather that let anyone ask, did the sun inhale at the moment the object sighed? The conclusion is not a curtain fall, but a raising of lights on a longer stage. 3i Atlas will fade. Every visitor does. It will carry away a few atoms of our curiosity, which it plucked from us the way a magnet plucks filings. But it leaves behind something heavier than dust, a refinement of attention. We will write better equations, we will build more patient machines, and we will allow ourselves to entertain at once the strictest discipline and the most luminous wonder. Whether the slingshot that seemed to defy our models was a parable about texture and pressure or a telegram from minds we have not met, the response is the same: learn and then go. We have sails to test and null hypotheses to break and a sky that keeps feeding us sentences in an alien grammar we are close to reading. Between the rigor of Cox and the audacity of Kaku, there is a bridge. We are already walking it, one careful, delighted step at a time. The future of space exploration is not only in louder rockets or stronger alloys, but in tenderness for subtle forces. Light as momentum, geometry as engine, patience as propulsion. 3i Atlas is already outbound, and we, smaller than we knew and braver than we feared, are falling into its slipstream with instruments outstretched and eyes bright, writing our reply in the only medium the universe never ignores: motion.